Okay, so today we're going to get into the dreaded SOHCAHTOA. I know Hager probably had some great jokes about this last year. So how SOHCAHTOA works basically is these are acronyms, kind of like SCUBA, like we talked about before, stands for self-contained underwater breathing apparatus. So is telling you what you need. So you have sine of an angle measurement, and I'm going to use theta, the Greek letter is an angle measurement, is the O opposite side over h the hypotenuse. Then the next one says ka. So I have cosine of an angle measurement is equal to A, which is adjacent over the hypotenuse. And then the last one, TOA, is tangents of an angle measurement is equal to the opposite side over the adjacent. Now, I struggled with this in school, I'm going to be honest. I struggled knowing where sides were. So here's the best way to do this type of problem is if you have a right triangle, okay, mark what side you have first. All right, so for example, if I choose this purple side here, or angle, excuse me, mark what angle you have first. If I choose this angle, all right, I know this side is my hypotenuse, this side is my opposite, this side is my adjacent. Adjacent means next to. So adjacent is part of the angle that you're discussing. So if you're discussing the purple angle, that would be part of this angle right here. So adjacent would have to be the side that meets the hypotenuse. However, if I switch my angle, you can always choose the acute, you can't choose the right angle. If I switch my angle to the other one, my hypotenuse remains the same. This side now becomes my adjacent because see how they make up the angle together. See that? And then this side is my opposite side. All right? Now, you've all seen this part before. However, I'm going to show you something new. There are actually 6 trig functions, okay? And they're called trigonometric functions, which honestly is a fun word to say. But these have inverses of them. So the sine's inverse is called the cosecant. All right, so we're going to flip hypotenuse and opposite. The cosine's opposite is called the secant. So that's going to be hypotenuse over adjacent. And the tangent's opposite is the cotangent. So that's going to be adjacent over opposite. So those are inverses of each other. And like Lewis always says, who was a navigator in the Air Force, he says, a pilot must have its co-pilot. So sine has cosecant, secant being the pilot has cosine, and tangent has cotangent. Okay? So for part of your homework, you have to figure out the 6 trig functions. All right, so let's run through how to do that. So let's say I told you on a problem in the homework that the secant of theta equals, let's go 10 over 7. Okay? So I'm going to draw my right triangle. I'm going to pick an angle. Doesn't matter where you pick your angle because I drew the right triangle, so I can pick wherever I want to. So I'm going to pick right here. So based on this angle, this is my adjacent, this is my hypotenuse, and this is my opposite. Okay? What's given to me in this problem is given to me that 10 is my hypotenuse. So at 10, or hypotenuse, I'm going to write a 10. And it's also given to me that 7 is my adjacent. So I'm going to put a 7 at adjacent. So I've got to figure out my opposite side first. Okay, so how do I figure that out? Well, that's old Pythagorean theorem. A squared plus b squared is equal to c squared. So I'm going to say, it doesn't matter which one's A and B, makes no difference. Okay, only that c is 10. So I'm going to say 7 squared plus b squared is equal to 10 squared. So b squared, let's see, 49 plus b squared is equal to 100. So b squared is equal to 51. Take the square root of that, and it becomes radical 51. There are no perfect squares that go into radical 51, so we're going to leave it like that. All right, so now we have to write our other 5 trig functions. We have this one. That's the one we have. We got to write our other 5. Okay. Okay, now remember, a radical can't be in the denominator. That's going to be key. So if I do sine of theta is opposite over hypotenuse. Opposite over hypotenuse. So radical 51 over 10. If I do cosine is adjacent over hypotenuse. So adjacent over hypotenuse. So that's 7 over 10. Tangent is opposite over adjacent. Opposite over adjacent, radical 51 over 7. All right, so those are my first three trig functions. Draw the line there so we can keep track. Cosecant. Cosecant is the opposite of sine. So cosecant, I can flip this fraction. However, the problem I run into is I can't have a radical in the denominator. So an easy way to cheat that system is bring your radical sign up and lose your radical sign at the bottom. Then you have to reduce if you can reduce on the outside, but this one you don't have to because 10 over 51 doesn't reduce. Cosecant, well I already have secant, but I'm going to rewrite it just for my own peace of mind. So that's going to be 10 over 7. And then tangent is cotangent, which would be 7 over radical 51. Again, the same idea as what we did before. I got to bring my radical up, so that becomes 7 radical 51 over 51. And those are how you write your 6 trig functions.